All right, on number 20, we have a wooden ladder is wider at the top. So, sorry, wider at the bottom than at the top. And it has 10 equally spaced rungs. So we've got 10 rungs in here. I didn't draw enough. The bottom rung is 22 inches wide, and the top rung is 14 inches wide. What is the total length of all the rungs put together? So I start out here with 14, and I go to 22. I have to be equally spaced, so that means I'm arithmetic, and I want to know the total length of all the rungs together, so that's going to be the sum of the series. So when I'm using my sum of a series formula, it's S sub n is n over 2 times a sub 1 plus a sub n. I'm going to use that formula because I know the first and the last term. For this one, it really doesn't matter which one we consider first and which one we consider last, because we'll get the same answer both ways. So how many terms do we have? What is our n? Well, there are 10 rungs, so n is 10. If this n is 10, then the n over here is also 10. And I'm going to divide that by 2. Then I'm going to add my first term, which I'm going to call 14 or 22. Again, it doesn't matter. And my last term, which I'm going to call 14 or 22, whatever I didn't use already. And then I want to calculate that. So let me go over here on my calculator. I'm just going to do the 10 divided by 2 in my head is 5. And then I have 14 plus 22. And my total length is 180. I will write my answer as a sentence with units. So let me do that. There we go. The total length is 180 inches. And that does seem about right. If you just thought if it was 20-ish and there were 10 of them, that would be about 200. So it's a good ballpark. All right, number 22. I have two geckos are having a race, of which can travel 20 feet first. So we have a leopard gecko, and the leopard gecko is walking at a constant pace, going 2 feet every minute. So our leopard gecko looks like this. He goes 2 feet, and then he goes 2 more feet, right? And so he's gone a total of 4 feet. Then he goes 2 more feet, so he's gone a total of 6 feet so far. So this is his total distance that he's gone, okay? Then we have our crested gecko. Our crested gecko is going to jump. He's going to jump a quarter of the distance to the finish line every minute. So our crested gecko, on the first jump, if it was 20 feet, he's going to travel a quarter of that distance. So a quarter of 20 is 5 feet. Now, on the second jump, he's going to do a quarter of the distance to the finish. So right now, he's got 15 feet to the finish because he went 5 feet, right? So he's going to jump a quarter of that. So I'm going to do 15 times 1/4 is 3.75. That's how far he's going to go the second time. So realize this is how much he's traveling, whereas the leopard gecko up here, I happen to write how much total he's gone so far. So it says, where are each of the geckos after 3 minutes? So the leopard gecko, I had already listed that out, was at 6 feet. The leopard gecko is 6 feet from the start. Okay, and then we're going to have the crested gecko. Let's see how far he's gone. The crested gecko is how far? Well, he started out and he was 20 feet away, right? So he jumped 5 feet, then he was 15 feet away. Oops, so he had 15 feet left to get to the end. Then he jumped another 3.75 feet, right? So hold on a second here. Okay, so I had to get some totals here. So I had started out and he had gone 5 feet at first, and then he had gone 3.75 feet for the second jump. So I need to figure out where he was at that point. So I put my 5 feet and the 3.75 feet together, which means he was 8.75 feet from the start. That's the total distance he had traveled. after that second jump. So now he needs to jump again. So if he was, and I'll come over here to my calculator, he was 20 feet originally was his distance from the start. He took away 8.75 feet because that's how much he is after the second jump. And now he's 11.25 feet from the end. So he jumps 25% of the distance from the end, means he jumps another 2.8-ish feet. So I take my 2.8-ish feet and add it to the 8.75 feet he's already jumped, and I have 11.562 feet total that he's jumped, which means the crested gecko is 11.562 feet from the start. Okay, so who will win and where will his competitor be at this point? Well, the easiest one to figure out is the leopard gecko, right? So the leopard gecko, he's going 2 feet every minute, so it's going to take him 10 minutes to finish, right? 10 minutes to finish. So let's figure out, where is the crested gecko at this point? Has he already won, or is he still back running? Okay, so I'm going to put some terms in my calculator here. So I would like for my calculator to be able to define this recursively, so I just need to do one thing to the 20 to figure out where I am after that. So rather than figuring out how far he jumps by taking a quarter, I'm going to say how far does he have left. So if he jumps a quarter of it, what does he have left? He has 0.75, or 3/4 of the distance left to get to the finish. So this would show that after one jump, he's 15 feet from the finish. And then if I hit enter again, after 2 jumps, he's 11.25 feet from the finish. After 3 jumps, he is 8.4 feet from the finish. So we have 10 minutes. So he jumps every minute, so that's 10 jumps. So this was right now at the end of the 3rd jump. So there's the end of the 4th, the 5th, the 6th, the 7th, the 8th, the 9th, the 10th. Now, if my gecko keeps jumping like this, and he always jumps a quarter of the distance left to the finish, there's always going to be some little amount at the end that he's never jumped, right? So we know that the leopard gecko has to win. But if we had to answer this question of where will his competitor be, that's why I need to keep going with my crested gecko. So I'm going to say the leopard gecko will win. And then as I found on my calculator, the crested gecko is still 1.126 feet from the end. Part C says, using appropriate sequence and series vocabulary, explain why the crested gecko will never finish. So, like I said, there's always going to be a little space left, but we would say the crested, here I'll write. Okay, so I said the crested gecko makes an infinite geometric series because he's multiplying by a quarter each time, or by 0.75, depending which way you're thinking of it. So since his R, his common ratio, is between -1 and 1, the sum will converge to 20 feet. But the series is infinite. It's going to keep going forever and ever. He will always have a little space left at the end. Right, let's go to 22 and 23 here. Number 22 says, find the sum of the even integers from 36 to 82 inclusive. So I'm starting with 36, and then if I'm dealing with even integers, my next one would be 38, 40, and so on. And I'm going to keep going until I get to 82. So if I'm going to do my sum formula, this is going to be arithmetic, because right here I have a common difference of 2, right? I'm going up by 2 each time because I'm the even integers. So in my sum formula, I need to know how many terms, S sub whatever, how many terms am I finding this sum of? I don't know that yet. But whatever it is, I'm going to divide it by 2, and then I'm going to add together my first term, which was 36, and my last term, which was 82. So I just need to figure out how many numbers are there between 36 and 82 inclusive. Well, I have a pattern over here. So since this is a pattern, it follows my arithmetic sequence formula. So in my arithmetic sequence formula, a sub n, which would be my last term, or 82, is equal to the first term, which for me is 36, plus n minus 1. I don't know what n is, so I'm going to leave that as an n. and then I have to multiply that by my common difference, which I had up there was 2. So I can use this formula for the sequence to solve for n, and then I can plug that in to my series formula. I'm just going to use my calculator for solving because it's easier. So I have 82, and then I'm going to subtract 36 to move the 36 over. I'm going to divide by 2 to move the 2 over, and then I'm going to add 1 to move the 1 over. You could write out all the steps for that if you want to, but what I've gotten is that n is equal to 24. So this is really now s sub 24 is 24 over 2. I'll go ahead and put that in my calculator. I've got 24 divided by 2 was 12, and that is times 36 plus 82. So the sum of the even integers from 36 to 82 inclusive is 1,416 is the sum, if I want to write this sentence. Okay. Last one, number 23. A person recovering from an injury is told to gradually stop wearing a knee brace. They are currently wearing the brace for 24 hours a day. So that's the first term. The doctor says to decrease the length of time by 45 minutes a day. So in this one, I'm decreasing by the same amount every day. So it's a constant change. That means it's going to be arithmetic. And I'm going to decrease by 45 minutes, which is 3/4 of an hour. So after the first day, if I did 24 hours the first day, decrease by 3/4 of an hour, in my second day, I'm wearing the brace for 23 1/4 hours. And I'm going to keep doing that until I'm not wearing my brace anymore, right? So how long will they wear their brace after 2 weeks? So for this one, n is going to be 14 days. And we're starting out with our formula, a sub n. So I'm looking for the 14th day. I need a sub n is equal to a sub 1 in my arithmetic formula. So a sub 1 was 24 for me. And then I do plus n minus 1. So I have 14 minus 1 times my common difference. And my common difference for this one is negative 3/4. So I'll just go ahead and put that in my calculator. I've got 24 plus, and I'm just going to do the subtraction on my own, 13 times negative 3/4. You can either put it in with the fraction button or put it in parentheses. Either one is fine. And we see he's going to wear the brace for 14.25 hours. So I'll write that out. He wears the brace for 14.25 hours. Okay? It says, after how many days will the person be able to get rid of the brace? So what we're looking for is figuring out when we get down to 0. So if I'm trying to get down to 0, I can plug into the same arithmetic formula I used up here. My first term was 24. We don't know what n is in this case, but whatever it is, I'm going to subtract 1 from it. And then my common difference was negative 3/4. So if I wanted to solve this equation by hand, I would start with 0 and I'd move the 24 over by subtracting 24. So I'm going to have negative 24 when I do that. Then I would move over the multiplying by negative 3/4. To do that, I'm going to divide by negative 3/4. Or you could have multiplied by negative 4/3, either way. And then after that, I'm going to add 1 to move the 1 over. So I'm just doing the order of operations backwards, and I get that n is equal to 33. Now that was a nice number of days, so my answer would be he can get rid of it after 33 days. If this were a decimal, I would have to think to round accordingly because we have to get down to 0. Okay, so, and there I just wrote it out as a sentence. He can get rid of the brace after 33 days. Okay, good luck.